once more to this YouTube channel, Best Science Brain YouTube tutorial channel. Today we are going to look at another aspect of organic chemistry. We're going to look at the topic on the board, how to draw the line formula or the skeletal formula of organic compounds. If you are yet to subscribe to the channel or you are seeing the channel for the very first time, move up to the channel's name, Best Science Brain. Then onto the channel's name, you're going to see subscription icon, a tiny bell or a button. Tap on the subscription only once and get subscribed to the channel so you see our video from time to time. Refer your friends, your classmates, your fellow science or engineering students to this channel. Then subscribe to the channel and then learn as you move along in both O-level, A-level, high institution work in organic chemistry. We'll also be doing the fundamentals of physics and mathematics courses here. So today we're looking at skeletal formula. First of all, we're going to start with alkanes, simplest hydrocarbons. Let's take an example of an alkane called butane. Butane is an alkane that has 4 carbon atoms. This is butane for us on the board. I know that for now you are conversant with alkanes, nomenclature of alkanes. If you don't know that, then go through our videos and see where we treated alkanes. Then this is butane. This is the molecular structure or the structure formula of butane. For us to draw the skeletal formula of butane, we'll look at how many carbon atoms we have here. They're all in a straight line. 1, 2, 3, 4. Then around this carbon, is there any other substituent we have? No, we only have hydrogen atoms around. So the skeletal formula of butane, we draw lines connecting the 4 carbon atoms. 1, so this is it. Number 1 carbon position, number 2, number 3, and number 4. So this is the skeletal formula of butane, or the line formula of butane. We don't need to place the hydrogen atoms. We represent the carbon skeleton, or single bonds all through. So that represents the skeletal formula of butane on the board. Another example we're going to take is, let's for instance, remove 1 hydrogen here and put in place of this, put CH3. This compound is called 2-methyl butane. We have done nomenclature of aliphatic compounds. 2-methyl butane. This is an alkane, quite alright. So how do we draw this skeletal formula? We'll have, let's look at the straight chain, the parent chain, 1, 2, that's the root name, butane. We'll draw out this first. 1, 2, you see? 1, 2, 3, 4. This is butane. Then we have a substituent, a group that is not hydrogen. Look at this substituent, methyl group. How we represent this methyl group on this skeletal formula? We draw a line pointing up on carbon number 2. And this line here represents the methyl group. So this is the skeletal formula of 2-methyl butane. Okay, now let us change the compound. Assuming that we have another CH3 here. Now what we call this compound in chemistry. This is a methyl group on number 2, another methyl group on number 3. This compound is called 2,3-dimethyl butane. So how would I draw the line formula? The parent chain is 4, that's the longest. I'll now draw the line, link the 4 carbon. 1, 2, 3, 4. At the parent chain. Then I see that there are key group, methyl group on number 2, and also methyl group on number 3. So I draw a line pointing on number 2. That line is the methyl group. There's another methyl group on number 3. I draw another one on number 3. So this structure represents 2,3-dimethyl butane. structure, let's say we have a longer chain. This is a pentane chain. The longest continuous carbon is 5. So this compound by Ayuka convention, 1, 2, 3, 1, 2, 3. So something is number 3. 3-methyl pentane. So how would I draw the skeletal formula? The parent name is pentane, the longest chain. So I'm going to connect 5 carbon atoms with a line. Let's see, number 1, number 2, number 3, number 4, number 5. This is pentane. Then the group methyl is on number 3. I'll now draw a line on this number 3. So this is 3-methyl pentane. So that's the line formula of 3-methyl pentane. So you see that? So let's say we have this compound CH3 here. Again, this compound then will change to 3-3-dimethyl. 3-3-dimethyl pentane. 3-3-dimethyl pentane. So how would I draw its skeletal formula? What I'll do, I'll get the parent chain 5, 1 meaning 5 carbon atoms. 1, 2, 3, 4, 5. And I have methyl groups, 2 methyl groups on number 3, the same position. So I'll draw a methyl group line here and also another line pointing downwards. So this is 3-3-dimethyl pentane. Compound on the board, a hydrocarbon. Let's name the compound first of all before we draw the skeletal structure. The longest continuous chain, let's get it. Count the stretch chain 1, 2, 3, 4, 5, 6. 6 carbon. Count the branch chain 1, 2, 3. This one is less, we discount 3 because it's not more than 6. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Less than 6, we discount it. 1, 2, 3, 4, 5, 6. Longest chain is 6. So we take the straight chain since one of the branch chain also gives us 6. So we can take the straight chain as our parent chain. Then numbering. We have a substituent here, have another substituent there. So from this end, this gives us number 2 carbon. From this end, 1, 2, 3, 4, this gives us number 4. So the end that gives us a small number is this end. We start by numbering from the left, 1, 2, 3. Of course, we continue 5 and 6. So the name of the compound, this is called methyl group. Methyl, this is 2 carbon, ethyl group, ethyl. So the compound name will now become 3-ethyl, following Africa order. E come before M, 3-ethyl, and then 2-methyl, 3-ethyl, 2-methyl ethane, that is 6 carbon. Then to draw the skeletal structure of this, I'm going to draw the skeletal structure of ethane, that is 6 carbon. So we're going to have it. Let's see. 1, 2, 3, 4, 5, and we take it up 6. So that's ethane drawn on the board for us. Then the methyl group, this methyl group is on carbon number 2. So a straight line indicates methyl group. Then the ethyl group is on carbon number 3. So how do I draw the ethyl group? We draw a line and then curve it. Because that means there's a carbon here and also another carbon there. This place have a curvature, a carbon, and that carbon that indicates 2 carbon. So this is ethyl. So this is the structure of 3-ethyl, 2-methyl ethane drawn for us on the board. 3-ethyl, 2-methyl ethane drawn on the board. As simple as that. So, having understood how to draw the structure or line formula of alkanes, we can now go to alkenes. Alkenes are known to have double bonds in their structure. Example of an alkene is, let me take an example here. This is called butene, or in actual sense is called but1ene. This is the functional group of alkenes. The number from the end of the carbon closer to the double bond. The end is this side. 1, 2, 3, 4. So this is called but1ene. So to draw the skeletal formula of this compound, what would I do? What I'll do is I'm going to draw a skeletal structure showing 4 carbon atoms. 1, 2, 3, and 4. So that is, this should be butane. To make it an alkene, how to bring in the double bond? The double bond lies between carbon number 1 and carbon number 2. So between 1 and 2, I place underline. So this is the skeletal structure of but1ene drawn for us on the board. But1ene drawn on the board for us. So how about that structure? I'm going to draw on the board and then see. Let's say we have 3-methyl but1ene. Maybe I have a methyl group here. I didn't put methyl group. So this compound will change its name. So if you are non-brain, start from this end, close to the double bond. 1, 2, 3, 4. So this is called 3-methyl but1ene. If I want to draw the line formula of this compound, I'm going to draw 1, that is 1, 2, 3, and 4. So this is the skeleton of butane. Then put the functional group between 1 and 2. I draw a bond here between 1 and 2. Then the methyl group is on number 3. This number 3, I draw a line down to present the methyl group. So this is 3-methyl but1ene. 3-methyl but1ene drawn on the board for us. Then I take an example of an alkene on the board. So that's an alkene. So let us look at the name of this alkene first before we draw the skeletal structure. The name of the alkene, the longest carbon chain appears to be the thread chain. 1, 2, 3, 4, 5. Then in non-brain, the carbon atoms. I have this the key group. The key group. The principal we call the functional group. While these ones are secondary substituents. So this group take a lower number compared to this other. So we consider both ends. The end that give this group a lower number will be this side. So we have 1, 2, 3, 4, and 5. So this compound is called 4,4-dimethyl. 4,4-dimethyl. This is 5-pent-2-ene. To draw the structure of this compound, I'm going to draw a skeleton for 5 carbon atoms. We have 1, 2, 3, 4, and 5. But what I've drawn here is pentane because of the single bond. To make it pentene, the double bond lies between carbon number 2 and 3. So this is 2 and 3. I put a double bond here. That is pent-2-ene. Then I go to the substituents. The substituents are on number 4 and number 4, 2 of them. So I put a line up and that line down. So that is the methyl groups on number 4. So the structure you see on the board is 4,4-dimethyl pent-2-ene. 4,4-dimethyl-pent-2-ene. So you see how to draw structure of alkenes, how to do the skeletal structure of alkenes. It's not a difficult task. You can do it yourself. It's not a difficult task. Have a diene. Dienes are olefins that contain two double bonds between adjacent carbon atoms. You can see the bond here. I have another double bond. So this compound can be called, here could be number 1, or you start from this end. So 2, 3, 4. So this compound is called, this but. We say buta because of plural signifying more than 1. Buta, position number 1 and position number 3. 1,3-diene, an isoprene unit, which is a monomer for natural rubber. Okay, it's not. This is not. This is a derivative. The isoprene should be 2-methyl-butadiene anyway. So having done that, to draw the skeletal structure of this diene, I have to you have 4 carbon atoms. So I'm going to draw a line joining 4 carbon atoms. 1, 2, 3, and 4. That is this butane skeleton. Then the double bond lies on between 1 and 2. I put the double bond between 1 and 2. Another one lies between 3 and 4. I put the double bond between 3 and 4. So double bond lies between 1 and 2 and between 3 and 4. So this compound, this is the structure of buta 1,3-diene. Buta 1,3-diene. So that is the skeletal structure. Now, let us remove this hydrogen and put methyl group here to get the isoprene unit, which is the monomer of natural rubber. So let's say we have this structure drawn for us. The name will change. This now becomes 2-methyl buta 1,3-diene. 2-methyl buta 1,3-diene isoprene. Now to draw the structure, skeletal structure, there are 4 carbon atoms here. I'm going to join the 4 carbon atoms on a straight line with line. That is 4 carbon. Then we position the double bond. Double bond is between 1 and 2. We put it here. Between 3 and 4, we put another one there. You have the bond between 1 and 2 and 3 and 4. Then you have the methyl group on number 2. With the line showing the methyl group on number 2. So this is the structure for 2-methyl buta 1,3-diene. 2-methyl buta 1,3-diene. So that is the structure. So that is it. It's not a difficult thing to do. Let's say we have this structure drawn for us. We have CH2, CH. Okay, let's put it like this. The structure 1, 2, I have hydrogen here. So you have this structure, this compound for us, and there's hydrogen here. Tetravalency, okay. We have this compound drawn. How do you name this compound, by the way? The longest chain here remains the thread chain 1, 2, 3, 4, 5, 6. If you count again, 1, 2, 3, 4, 5, 6, remains 6 again. 1, 2, 3 is short. 1, 2, 3, 4, 5, 6. Longest chain is 6. So both branch and thread. Some branch chains and thread, and the thread will give us 6. So we take the straight chain at the longest continuous chain here at the parent chain. So this can be the longest, taken as the parent name, because the branch chain did not exceed 6. So to name the compound, so this is number 1. This will give us a smaller value compared from this. This one will give you 1, 2, 3. So this will be 1, 2 to this subsequent. Why this subsequent here? will give us 1, 2, 3. So prefer the lower end. 3, 4, 5, 6. This group is called methyl. 2 methyl on number 2. This group is C3H7, but you see it's branched. So we'll call it isopropyl. 2 methyl hyphen 4 isopropyl. If you look at the letter M, comes before P in English alphabet. So methyl comes before propyl. 2 methyl 4 isopropyl is this structure. So how do we draw the skeletal formula? There are 6 carbon atoms here. So I'm going to draw a line connecting 6 carbon atoms. 1, 2, 3, 4, 5, and put another one, 6. So 6 carbon atoms. Then we'll put the substituents. Methyl group is on number 2. We'll now put this methyl on number 2. Isopropyl is on number 4. Here we'll put this branch here on number 4. You see the structure. So that is the structure of 2 methyl 4 isopropyl. 2 methyl 4 isopropyl hexane. So you can put also it up when you want to put in a trans or cis position. So 2 methyl 4 isopropyl hexane. That is structure shown on the board for you. Then, having done that, we're going to look at the alkynes. How to draw the line formula of alkynes. Alkyne, example of alkyne is this structure I want to put on the board. Alkynes are known to have triple covalent bonds. So this is an alkyne on the board. So this alkyne has a name. Be the functional group. We'll number from this end closer to it. 1, 2, 3, 4, and then 5. This alkyne is called a pentyne compound, pent1I. Pent1I. So to draw the structure of pent1I, what would I do? I'm going to draw a line connecting 5 carbon atoms. So that is it. 1, 2, 3, 4, 5. This is pentene. Then the triple bond lie between carbon number 1 and number 2. Then I'll put the triple bond here. And that one line and another line. Triple bond between carbon number 1 and number 2. So that is pent1I drawn on the board for us. Pent1I on the board. For instance, that is it. What if we remove one hydrogen here and put CH3? This compound will now turn to 4-methyl pent1I. So how would I draw this one now? I'm going to also connect the pent means 5 carbon. 1, 2, 3, 4, 5. The functional group lie between carbon 1 and 2. I put it the triple bond here. While the methyl group is on carbon number 4, I'll put the methyl group here, CH3. So you see that, number 4. This is called 4-methyl. Sorry, the methyl group not appear because the line has already been shown. That indicates the methyl group. Yeah. 4-methyl pent1I. So having understood how to draw the structure of skeletal of alkynes, we'll now move on how to draw the structure of cyclic compounds. Let's start with the cycloalkanes. Cycloalkanes. So, for instance, we have this compound. This compound drawn on the board here is called cyclopropane. Cyclopropane. So if you want to draw the structure of this cyclopropane, I'll remove the whole carbon and hydrogen atoms, and that will give me nothing but a triangular shape. This is cyclopropane drawn for you. So if I draw this structure for you on the board, this compound is called cyclobutane. Now, to get the skeletal formula of this compound, cyclobutane, what would I do? I'll just draw a rectangle, removing the whole carbohydrate. This is cyclobutane. The same manner, if I draw this in chemistry, count the size 1, 2, 3, 4, 5. This is cyclopentane. As simple as that in chemistry. Now let's look at the cycloalkenes. Cycloalkenes. How do we draw the structure of cycloalkenes? For instance, I have this drawn for you. So that is this. This is called cyclobutene because you are seeing a double bond. Cyclobutene. Okay? No bond is given to you there. Cyclobutene. What if I put a structure here, a line here? What would I call this compound? Or how would I name it? This a line represents methyl group. And this is the functional group, double bond. Numbering it, I have to number from the carbon atom or the functional group. You have number 1, number 2, and number 3. I can't go like this. If I go like this, it will be 1, 2, well, you see the same, no? That's the right way is like this. 1, 2, and 3. So this is a methyl group number 3. Now I say 3-methyl cyclo is butene, cyclobut. Out of the two numbers, I take 1, the small number, but 1 in. So you see how to draw the structure. If I draw this triangle and put a bond here, this is called cyclopentene. Sorry, cyclopropene. Propene, not pentene. That is it. So having done that, draw the line formula of haloalkanes. Let me take an example, a simple haloalkane on the board. Let me put chlorine here. A very simple one. For haloalkanes, this is called 1, 2, 3, no? The position here is lower, 1, 2. This is called 2-chlorobutane. To draw this structure, or this line formula, what I'm going to do is, there are 4 carbon atoms in butane, and it's a saturated compound, so 4 carbon atoms, single lines only, 1, 2, 3, and 4. They will have chlorine on carbon number 2. You draw a line on number and then put chlorine atom there. Because chlorine is not a carbon. Chlorine will appear because chlorine is not carbohydrate atoms are the ones removed, but chlorine will appear. So this is the structure of 2-chlorobutane, a haloalkane. 2-chlorobutane, a haloalkane. Let's say we have a group here, CH3. Let's modify the compound. CH3 number 3, number 4. So in terms of nomenclature, this is called 2-chloro-3-methyl-butane. How would I draw the structure of this compound? I'm going to get 4 carbon, 1, 2, 3, 4. Then I have chlorine on number 2. 2-chloro, I put chlorine here, Cl. Then this is methyl. Methyl represents the single line. So they got the group carry carbohydrate, remove the carbohydrogen. So this is the structure of 2-chloro-3-methyl-butane. So in the skeletal formula, lines appear only if the compound is a hydrocarbon. But when you have other groups, other functional groups, you have to present them. So that is it. So when you have one line, it means a methyl group. If I put a line like this, covering 2 carbon, that means a ethyl group, 2 carbon. Then if I branch that line, that means isopropyl group. So having done that, we take another example. Let's say another example of a halocane. Maybe we have this compound, or you on the board, bromine, bromine here, hydrogen, 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 hydrogen. So that is it. Compound number 1, this is called 2,2-dibromobutane. So how to draw the skeletal structure of this compound? I'll get the number of carbon 1, 2, 3, 4. Bromine is on number 2 of the bromine atom. So I'll draw a line here and put bromine on top. Draw another line down and put bromine also down. So this is 2,2-dibromobutane. 2,2-dibromobutane. So no matter how funny the structure looks, you have to be able to decode it very well and to name it. So you see the way it's being done. So having done that, we are now moving to alkanols, namely the monohydric alkanols. How to draw the skeletal formula of monohydric alkanols. For example, let's look at this on the board. So this compound on the board has 5 carbon. Don't get it, is 5. Now this is a functional group. 1, 2, to start with the end to name. Number 8. 3, 4, 5. This compound is called pentan-2-ol or 2-pentanol. To draw the skeletal formula of this compound is not difficult. You just draw lines for 5 carbon atoms. So you have 1, 2, 3, 4, 5. This pentention. Then the hydroxy group that the function is on number 2. On number 2. So you put a line on that number 2 and then bring OH. Why did this group appear? Because this group is not a group of carbon hydrogen. So it will appear as a functional group. So this is pentan-2-ol. Pentan-2-ol. Then what if you modify the compound and put CH3 there? Well, CH3 compound modified. So how do we name this? Then name it first before we draw the structure. This compound is now called, this is number 3. 3-methyl-pentan-2-ol. To draw the line formula of this compound, what do we do? We get the root name, and that's pentane. 1, 2, 3, 4, 5. 5 carbon. Then the functional group is number 2. We now put OH. Pentan-2-ol. The alkyl group is number 3. That is, we put 9 here. We don't put it because the alkyl group of carbon and hydrogen, we don't represent it. Just the line represents the alkyl, the methyl group. So the compound you have there is 2-methyl-pentan-2-ol. 2-methyl-pentan-2-ol. So you see how this is done. 2-methyl-pentan-2-ol. That is it. What if we have this structure on the board given to you to name in the examination? What will you call it? Yeah, it's a structure of organic compound, a cyclic compound. To name the compound, what we're going to call it. So this is the functional group, that's the major group in the compound. This is also a substituent group. So number from this carbon, the carbon atom here. Number 1, we check round. Number 2, number 3. So if we move like this, 1, 2, 3, 4. This end gives us a higher numbering. So we prefer the lower numbering, like this side. So this is, so this group here, this branch, there's a carbon here, there's 1 carbon here. In actual sense, 1 carbon, another carbon. T thread is propyl, but the branching shows is an isopropyl. So on number 39, I said this is called isopropyl. Isopropyl. Then this is in cyclic form. When I say cyclo, and has 5 carbon in all 4 5, pentan 1 all, where the hydroxy group is. 3-isopropyl, cyclo, pentan 1 all. 3-isopropyl, cyclo, pentan 1 all. So we have come to the end of this tutorial. So I hope you enjoyed the lesson. Enjoy it. So pass the knowledge on to others by sharing our YouTube video to your friends. Then subscribe to the channel. Remain connected and learn with us as we treat both O-level, high institution work, and also we do practicals here and then solve problems on part of the examination questions. So we cover all aspects of chemistry, both physical chemistry, organic chemistry, analytical chemistry, chemistry, and so on. So remain connected. If you are not subscribed, tap on the subscription button and get subscribed to the channel. Remain connected as we bring you the best. Thank you.